This video tutorial talks about some of the principles and best practices to be used for managing large files. We have several features in RobotMaster in optimization and simulation that are good for trimming style toolpaths where the point numbers are small. But when we look at milling applications where the program can be hundreds of thousands of points or even into the millions, some special practices may want to be used so that handling files of those sizes become more manageable. On the screen here, you see an optimization map of a program that contains about 36,000 points. This took about a minute to generate on my computer. Now, many times handling files of this size, you click on calculate to generate the maps, only to discover several minutes later that everything is fine and you didn't really need to generate the maps. So we've implemented a couple of new features. One of them is called Generate Maps on Errors. And what this does is I'll just exit the local settings and come back in. So you see we have no maps generated and we have Generate Map on Errors checked. Now when I click on Calculate, instead of taking a minute, the calculation takes about 6 or 7 seconds, and very quickly we calculate to see if the program has any errors. If there are no errors, then the maps are not calculated. If there are errors, then the maps are calculated to allow you to see where the problems are and to avoid them. So this one feature is a significant time saver when working with large files. A couple of other things you may want to keep in mind. Whenever you're working with large files and you want to speed up your time, there are features that will slow down optimization. One of them is advanced layers. So this is something that you would want to uncheck. And then check between points. This would slow down the calculations by about 5 to 6%. Therefore, if you really want to save 5 or 6% on calculations, you may want to uncheck this as well. However, there is one other feature that we are very excited about, and that is the optimization density. By default, full density means we're calculating every single point when we are generating our optimization maps. But what we've done is we've now included a density of fine, medium, and coarse. And what this does is the following. Coarse means we will only sample up to 10,000 points in the program to generate the maps. Medium means we will sample up to 50,000 points, and fine means we will sample up to a maximum of 100,000 points. So now if we click on coarse and we go ahead and generate our optimization maps for this file, we will see that instead of taking 1 minute, it takes roughly around sorry, I'm going to have to redo that again and remove this because we don't have any errors. And click on calculate. So instead of taking a minute, the calculation takes roughly about 15 to 20 seconds, which is about a 1/3, which is about a 2/3 time savings on a 36,000 point file. If you had a 100,000 point file, it would be a 10-fold improvement in speed. Now, what is the influence of the optimization density on the maps? In this case, we don't see a major difference, but at times you'll see these little white lines, and that's just a result of the sampling that we have taken. So coming back to some of the options here, if we want ultimate performance and speed for large files, we would want to uncheck the check between points. We would want to check generate maps on errors. We would want to uncheck the use advanced layers, and we would want to set optimization density to coarse. This would give us the optimal settings for managing large files. Now coming to tool orientation, resolution also has a big influence on the speed. By default, we're at 7.2 in terms of resolution. And we can bring this down. So we could bring it down to 18-degree resolutions or 20 steps, or we can bring it down even more. And the lower the resolution, again, the quicker the optimization. Now, this is a general overview. We're going to follow with some charts just to show some numbers and some toolpath sizes that we've tested internally on a benchmark computer. And then we will follow up with some hints and suggestions for simulation and load up. for managing large files, this is a summary of some of the settings. Ideally, you would want to put the resolution as low as possible to get the job done. Secondly, you should not select check between points because that adds additional calculations. You should check generate maps on errors so that if there are no errors, no maps will be generated. And you should avoid advanced layers if you don't need that additional data. And of course, the best possible way to get performance is to set optimization density to coarse. Now, this is a little chart, and what it shows is various program sizes and the time it takes for optimization to check only the path. So for a 36,000 point file, only 5 seconds is necessary to check the path. For a 112,000 point file, 13 seconds. Double that at 224,000 point files, that would take 26 seconds. For almost a 500,000 point file, 53 seconds, and 110 seconds for a 900,000 point file. Now, if there are no errors, this is a very quick way of checking to see if there is an issue. Now, if there are errors, there's things that can be done. We took a 448,000 point file, so almost a 500,000 point file, and we used V5 or the same settings as in V5 without any of these new performance enhancements. And we got an optimization with maps being calculated at about 510 seconds. That's a little bit over 8 minutes. Now, we checked generate map on errors, and there was no error, so just the determination of if the path was good or not took 37 seconds, which is a fraction of the time compared to 8 minutes. And then we also generated the maps using coarse density, and that took 158 seconds, which is a little bit over 2 minutes. Therefore, even if you need to generate the maps, you can do it in a fraction of the time that it took in V5. Now, talking about managing large files, let's look at a couple of other settings. One that is important to always have checked is in the settings in simulation, calculate upon startup of long toolpaths. If you do not want simulation to do a calculation when you load up simulation, you should uncheck this option. Therefore, what would happen is that when you load up simulation, it does not calculate automatically. This will allow you the liberty to decide when you want to calculate, saving a processing time. Another setting is on the calculate button. You may want to check without collision detection. Therefore, if collision is an issue, then you can check that and it will take a little bit longer to calculate. Now, we have done significant improvement in collision detection, and this chart shows us some comparative numbers for various program sizes with and without collision. Now, when the point number is relatively low, the difference is negligible. For instance, for a 36K point file, without collisions, it took 3 seconds to calculate. With collisions, it took about 7 seconds. For a 112K point file, 8 seconds without collision and 22 seconds with collisions. But as the point numbers start getting higher and higher, like for a 448K file, no collisions takes 32 seconds, and with collisions takes 89 seconds. Therefore, imagine loading up a 500,000 point file with collisions will take you about 1.5 minutes. Therefore, it may be wise to check without collision detection by default and only use collisions if necessary.